All right, back to the same topic, finding displacement, velocity, acceleration graphically. So far, we were dealing with slope or gradient of a graph. Now we will switch our attention to area under the graph. So what do I mean by that? If the question has given us acceleration time graph and the question asks us to find the change in velocity. So how do we do it? We will find the area under that graph. So the rule is area under an acceleration time graph gives change in velocity. So we are going to solve questions based on that. Secondly, if the question gives us a velocity time graph and we are supposed to find displacement, so again, we'll do area under the graph. So the statement is area under a velocity time graph gives us displacement. And let's solve a question based on this principle. So here we have a graph which is speed versus time. Object is moving in a straight line. Now, since the object is moving in a straight line, distance and displacement will be equal, which means the speed and velocity also will be the same. So, even though in the graph the y-axis is speed, so we can very well consider the y-axis as velocity. And that is because the object is moving in a straight line. So, we have a velocity time graph here, and we need to figure out the distance traveled by the object during the first 2 seconds. Now, remember the rule, the area under a velocity time graph will give us the displacement. So we need the time 2 seconds. So what we'll do at the point 2, the graph is over here. So this point, let us consider this point as point P. So let's me label this point as P. So step number 1, starting from P, we draw a dotted line which is perpendicular to the x-axis, and then we shade the area. And which region is that? So this entire region, area, is what we are supposed to find. Area under the curve means area between the graph and the dotted line and the x-axis. Incidentally, this is a right angle triangle. And how do we find the area of a triangle? It's half base into height. So in this case, what's the base value? It is 2 and the height of this triangle is 10. So the area of this triangle will be half multiplied by 2 multiplied by 10. And if we solve this, we'll get 10. And since we have to find the distance, that is why the unit for this will be 10 meters. Hence, the option C is the right answer for this question. In this question, a velocity time graph is given. We need to figure out the final displacement of the body. Remember the rule, if you have a velocity time graph and we need to figure out the displacement, all we need to do is area under the graph. Now, in this case, total time is 9 seconds. How do we find the area? First, let us try to shade that region. From 0 to 6 seconds, consider this triangle. So let me shade this entire region. This entire triangle area is what we are supposed to find. That will give us the value of displacement till 6 seconds. Let us try to figure out that value. So let's write S. Let's say S stands for displacement. So displacement from 0 to 6 seconds will be equal to area of this triangle, which is again half base into height. The base of this triangle is 6 and the height is 10. So let's simplify. The area of the triangle will be half multiplied by base is 6, height is 10. And now if we simplify this, we will get 30 meters as the answer. Similarly, from 6 to 9, we need to find the area under the curve. Now, please do remember area under a curve. This word is a little misleading. When we say area under the curve, what we actually mean is area between the graph and the x-axis. So let me shade the region which we require. So this is that region whose area will give us the value of displacement. So let me write the displacement from 6 to 9 seconds will be equal to area of this triangle. Base of this triangle is 9 minus 6, which is 3 units, and the height of this triangle is 10, but in the negative direction. So we can take minus 10. So area of this triangle will be half multiplied by 3 multiplied by negative 10. And if we simplify this, we will get negative 15 as our answer. But the question wanted us to find the total displacement. So we will add these two values, 30 plus negative 15, which means let's write down the total displacement will be 30 plus negative 15, which is just 30 minus 15. So that will give us 15 meters as the answer. Hence, the final displacement of the body is 15 meters. Hence, the final displacement of the body is 15 meters. Next off, we have to describe the motion of the object. So it is important for you to read the graph accurately. So how do we do that? So look at this table. From 0 to 3 seconds, the graph is a straight line passing through the origin and it is increasing. So initial velocity is 0, final velocity is 10. So that's what I have mentioned here. From 0 to 3 seconds, the velocity goes from 0 to 10. And what is the distance traveled in the 3 seconds? That will be the area of this small right angle triangle. So consider this big triangle. If you divide that in half, so this small little triangle, where my cursor currently is hovering, that will give us the value of displacement traveled by the body in the first 3 seconds. That will be 15 meters. Now, since it is positive 15, that's why we can say the object is going towards the right hand side. Similarly, from 3 to 6, the velocity is going from 10 to 0. That's what I've represented here. And the area of the graph between 3 to 6 seconds is also 15 meters. And like in 0 to 3 seconds, 3 to second graph is also above the x-axis, which means area is positive. And that is why from 3 to 6 seconds, the object is traveling 15 meters, but to the right hand side. From 6 to 9 seconds, at 6 seconds, the velocity was 0. At 10 seconds, at 9 seconds, the velocity is negative 10. So, what is the implication of negative sign? Negative sign only represents the object is going to the left hand side. So, from 6 to 9, we had figured out the displacement was negative 15. So, the object is traveling 15 meters to the left hand side. And that is how we analyze graphs and we try in this question, we have been given acceleration time graph. So let's read the question. An object is traveling with a velocity 5, which means this is the initial velocity. The object accelerates to 15 meters per second in the same direction. What is the variation with time of the acceleration of the object? How do we approach such questions? So remember the rule. If you have been given an acceleration time graph, and if we can find the area under the graph, that will give us the change in velocity. Now, before we do that, let's try to find the actual change in velocity. Initial velocity is 5, final velocity is 15 in the same direction, which means we can write change in velocity is final velocity minus the initial velocity. Final is 15, initial is 5. So we get 10 meters per second as the change in velocity. So all we need to do is to check in which of these options the area under the graph is equal to 10. Let's go option by option. In option A, this is a triangle. So what will be the area of this triangle? Half base into height. Base of this triangle is 5. The height is 10 approximately. So let's write down the area of this triangle will be half multiplied by 5 multiplied by 10, which comes out as 25. So clearly 25 is not equal to 10, which is the change in velocity which we require. Hence option A is clearly wrong. That's not the right answer. If you look at option B, this is a right angle. If you look at option B, this triangle is similar to the triangle in option A. So base is the same, 5 meters, height is 10, which means the area in option B is also 25, which means option B is also incorrect. Option C, this is a rectangle. Area of a rectangle is base into height. So height of this rectangle is 10 and the base is 4 minus 2, which is 2 meters. So let's write down the area of this rectangle will be 2 multiplied by 10, which is 20. Now 20 again is not 10 meters per second, which we require. So option C is also wrong. In option D, the base of the triangle is 2 units and look at the height. Height is 5. So area of this triangle will be 2 multiplied by 5, which comes out as 10, which means this matches with what we were looking for. The original change in velocity was 10 meters per second, and only in option D, the area under the graph is equal to 10. Hence, option D is our answer.